So hello guys, I'm back again with another live stream. I'm sorry I'm little late because I had an ECG or blood test today, so I got late because of that. But now I'm back, so we'll be solving again. Same, we'll be solving DSA questions and CP questions as much as we can in our time duration. Let's see. Hope for we will be going for long hours today. And yeah, so we can start from here. So as usual, I'll be doing 50 minutes of DSA and then 10 minutes of break, and in 50 minutes of DSA, and in between I'll be taking maybe a 40 minute or 50 minutes of break for lunch, and after that we can again start the streaming. So this is how I am planning to do things. So sorry, let me connect my whiteboard. Just give me a minute. All the best for reports. Thank you. uh, let's see क्या होता है रिपोर्ट में. Okay. Okay, so we can start now, I think. So let me start my Pomo Focus.io. Pomodoro. And let's start. All the best. So let's pick this question. Manhattan permutation. I don't know why this code forces have changed. What does this enter and register? Remember me for a month. And forever. Okay, so let's start with Manhattan permutations. Can I shift it to the right? No. Okay. Let's call the Manhattan value of permutation P the value of expression P1 minus 1, P2 minus 2, dot 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 Pn minus n. For example, I think I've seen this question. or the previous stream maybe. I didn't solve this question. Let's call the Manhattan value of a permutation P the value of expression P1 minus 1, P2 minus 2. For example, for the permutation 1, 2, 3, the Manhattan value is 1 minus 1, 2 minus 2, 3 minus 3. And for the permutation 3, 1, 2, the Manhattan value is 3 minus 1, 1 minus 2, 2 minus 3. That is 4. You are given an integer n. Okay, find the permutation P of length n. Okay. Such that its Manhattan value is equals to k, or determine that no such permutation exists. A permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. For example, 2, 3, 1, 5, 4 is a permutation, but 1, 2, 2. Okay, it should be a distinct integers and it should be within n range. 1 to 2 is not, because 2 is appearing. 1, 3, 4 is also not a permutation. N is equals to 3, but there is 4 in the array. So whatever n is there, we need to follow those numbers only. If n is 3, we can go up to 3. If n is 4, we can go up to 4, and we have to go up to 4. That is what it is saying. Yeah, I think we did explore lot of ways last time for this, for finding. I don't know we were able to do it or not. Let's see. Let's try it once more and let's see. If not, then we can see the solution also. Okay, so we have total of 8 test cases. First n is 3 and we need to make the sum as maximum as 4. So we can take numbers as 1, 2, 3. We can take any permutation of this 1, 2, 3, either 1, 2, 3 or 2, 1, 3 or 2, 3, 1 or 3, 1, 2 or 3, 2, 1, 1, 1. And in any case, I need to subtract it with 1, 2 and 3 and check what is the value that is coming, and I need to make it 4 and I need to give some permutation. So like this is the answer 3, 1 and 2. If I subtract 1 from 3, I'll get 2, plus 2 from 1, I'll get 1. It's mod, right? So it's modded value. And 3 minus 2, that will be 1, so it will give me 4. So 4 is my answer, and which is correct. Now in this case, if I subtract this with 1, we'll get 1 plus 1 plus 0, which will give me 2. This will give me 1 plus 1 and plus 2. This will give me 4. So this can also be one of the possible answer. 3 1 2, obviously we saw that this will give me 4 here. Subtracting 1 will give me 2, plus 2 will give me 0, plus 3, this will also give me 4. So any of the 3 we can return as our answer. Now which one to follow? Let's take another example. We have 4, so 1 2 3 4, and we need to give 5 as a sum in total. See, what is the maximum sum that we can make from this? What maximum sum we can make from this is if we go from back 4 3 2 and 1, we can create a maximum sum by subtracting these. 4 minus 1 will give me 3, plus 3 minus 2 will give me 1 plus 1 plus 3, 6 7 8. So 8 is the maximum that I can go. If it is beyond 8, if it is more than that, my k value, then we won't be able to make it. So in that case, it's a no. And if it is a yes, then whether it is possible or not, that we need to check. We also check that we cannot make any odd numbers. Odd sums were not possible last time we checked. Even sums, not sure about even sums. Even sums can be made depending on the conditions. So for even sum, what can we do? 4 minus 3. So if we go from back, why let's see, I want 5. So if I place 1 over here, so we are replacing two numbers. We are replacing 1 and 4 from its actual place. So if I place 1 over here, I can get a sum of 3, and I need 2 more. If I place 2 over here, I can get a sum of 1. I need 1 more. If I place 3 over here, I can get a sum of 1, which is my answer. Now I don't want this to be replaced. I want 1 over here, but I can't. I have to place 4 over here. I will have to place 4 over here. In that case, what if we place 1 over here, And now I know I have consumed the place for 4. Now I need to place 4 somewhere. So now I have placed 1 over here. I already have 3. I need 2 more. If I place 4 over here, I'll get 2. And let me place 3 over here and 1 over no, not 1 over here, 2. No, if I'm placing 2, I'm consuming the space for 2 also. Even I need to arrange this in some order. If I'm placing 1, I am replacing 4, and in place of 1 I need to place some other character. If I place over 4 over here, I can place 2 3 over here. That is fine. So if I'm replacing 1, that one place needs to be replaced with some other character, correct? So if this is 3, this will also give me 3, which is nothing but 6. And this is 0 0. Right. Now if I do not do this, if I place 1 over here and I place 3 over here, I can place 2 over here. So this will give me 0, this will give me 2, and this will also give me 2, which is 4. if I want to make 6, if I want to make 8, I'm still not able to reach 8, because this will give me 3, this will give me 3. So replace these also. Will give me 1 1. Now it's possible to get 8. Okay, 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 okay. Now I think we are getting somewhere around. Let's do for another test case. We have fifth test case as 8 and 14. Let's see. For 1 2 3 4 8, I need to make sum of 14. I know I can maximum go, if it is possible, if I can go till 14 or not. So if I'm placing 1 over here, I'm I'm calculating an answer as 7. So this 7, and if I place 8 over here, this will also give me 7. 7 plus 7, that is 14. And for the rest of the character, I can place directly 2 3 4 5 6 7. I can only I should only replace these two characters, right? So 14. Now suppose I need an answer as 8 from here. So if I place 1 over here and 8 over here, that will give me 14. That is going beyond my 8. So I will not place 1 and 14 over here. So let me mark 1 and 8 as it is. Instead of 7, if I place 2, or instead of 7, I place 1, and from here 7. So this will give me 6. This will give me 6. That is 12, which I do not want. Still going beyond. So this, let me place 7. Now if I place 1 over here, 6 over here, this will give me 5, and this will give me 5, 10, which is still going beyond. Give me a minute. I think Cook is here, so I'll be back in a minute. Sorry. Okay, I'm back. Okay, so where were we? So this will give me 8, which I don't want. So let me place 6 over here. Let me place 1 and 5 over here. The If I place 1 over here, this will give me 4, and this will also give me 4, which is what we want, which is nothing but 8. So we can get 14. We can get from here we can get 14. We can from here we can get 12, 10, 8. I suppose if we place also 1 over here and 4 over here, this will give me 3, 3, 6. We can also make 6. I'm placing 4, placing 1 and 3 over here, which will give me 2 and 2, which is nothing but 4. So we can make 4, 6, 8, 10, 12, 14. Okay, and even if we place 3 over here, we place 1 and 2, we can make 1 and 1, which is nothing but 2. So we can even make 2. So 2, 4, 6, 8, and 0. So 0, 2, 4, 6, 8, 10, 12, 14. So we are always making even sums. We are not making odd sums, because whatever one, if we cannot change a single place, right? We need to change at least 2 places, which should be there, which will be changed. So changing one place is not possible. So for that we need to change 2 places always. And if we are changing 2 places, that sum, even if it is odd plus odd, will give me even. Even plus even will give me even, and it'll never be odd, even odd sum. It'll be either even or odd. So this way we will be able to make things work. Let's see if everything is working fine for other test cases also. So for this it's no, because it's an odd simple. 5 and 12. Let's make 5 and 12. 1, 2, 3, 4, 5. Why so bold? Okay. So we need to make 12 out of this. So if we place 1 and 5 over here, that will give me 4 and 4, which is nothing but 8. Now 8 is smaller than 12, so let's take it. So 1 and 5 is consumed. Now we are left with 2 and 4. If we replace them, if we change their places, so we place 2 here and 4 here, we'll get 2 plus 2, that is 4. So 4 plus 4, that is 8. 2 plus 2, that is 12. And place 3 over here. So this will give me 0, and we are close to our answer. 5, 4, 3, 2, 1. Even 1, 2 will do it. Wow, but 5, 4, 3, 2, 1 will also do it. Now for the last 5 and 2. So 1, 2, 3, 4, 5. I need to make 2. If I place 1 here and 5 here, we'll make 4 plus 4, 8, which is greater. So I should not do that. Let me place 5 here. If I place 1 here and 4 here, 1 here, 3 plus 3, that is 6. Still more, so place 4 over here. If we place 1 here and 3 here, so placing 1 will give me 3, 2 and 2 plus 4, which is also not possible, which is also greater. So place 3 over here. If we place 1 here and 2 here, which will give me 2. So 2, 1, 3, 4, 5. 2, 1, 3, 4, 5. 2. So this way we are able to make our answer possible. The answer that can go till 10 to the power 9. Let's make Manhattan permutation dot cpp all files. Fine. So we are getting times, and in times we are getting two values, int n and k. And k. So from solve function we'll be getting a method. We'll be getting a vector resultant based on this n and k. And now if result dot size is equals to 0, that means it is not possible. So I'll simply no and Wendell. Else so we are getting two variables, integer and integer k. Now I need k is my sum that we need to make. Let's create a vector integer result of size n. So int I is equals to let's apply for loop I is less than now no we should start from last. Maybe I'll go from n minus 1 greater than equals to 0 and minus minus I. Now what I need, if I'm at last, that number will be twice. Like I need to find the start position and the end position. So my end position is nothing but this I only. My start position is my how I'm calculating the start. Oh shit. Where? Okay. So my start will be my so that will be I n minus I symbol total n is nothing but n minus I plus 1. If n is 4 and I starts from 3, because I will start from 3 third index, so n 4 minus 4, which will give me my start position as 0, and if I is 2, so 4 minus 3 will give me the start position as 1. So so this is my start position, this is my end position. Now there will be value no this will return. Let's handle the base case first. Now if my k modulo 2 is not equals to 0, that means it's an odd number, so I'll simply return an empty array. And if it is greater than the value which we have, so that also case should be handled. Like suppose if we have 4, so 1 2 3 and 4, if we do 4 3 2 1 we are getting 3 1 1 and 3 6 7 8. So the 8 is the maximum that we can make from here. Eight is the maximum that we can. If something is greater than 8, then we won't be able to make it. So if k is not, so at last we can check if k is not equals to 0, k should be equals to 0. If k is equals to 0, let me handle that case separately. So for this value I need to know the position and we are placing 1 over there. So suppose the position is I plus 1. I plus 1 is the position that minus 1 will give me the value, and I need twice of this. The condition is if val is lesser than or equals to k, then we can do this swap anytime. So so I need to have something which will tell me what value I am placing over here. I'm always not placing 1. Correct. That place val will be started from now. So the value which came is lesser than or equals to k, so I can swap the numbers. So so swapping of number will go how will go something like my place val is 1. If my place value is 1, the opposite place value will be what? If I'm placing here 1 at end, if I'm placing end is equals to place val, I need to place um, something at start. So I need to place something at start, which will be n minus place val plus 1. Minus 1, sorry. So place value was 1, this will give me 0, and n is 4, so 4 will be placed. Now if I'm placing 2 over m, my place value is 2, so 2 minus 1 will give me 1, 4 minus 1, that is 3, so I need to place 3 over there. So at result of end will be updated with place val, and result of start will be updated with n minus place val minus 1. After doing the updation, I need to increase the place val. And k minus is equals to val. From k, that value will be removed. So one thing that I can do in this, let me place it with 1 2 3 4. Initialize it with something. Yes. And at last if result if k is greater than 0, if still greater than 0, return, what should I return? Return an empty, else return result. So For first, it gave me 3 to 1. For second, it was odd, that's why it gave me no. For third, it was 0. K is already 0, so it gave me 1, 2, 3, 4, 5, 6, 7. For fourth, it gave me no. For fifth, 8 and 14. I also got for the sixth test case as no, but it should not. So the fifth one. Okay, what mistake did I do? Let's see. So we have 8. So I 4, 5, 6, 7. My place value is 1. My K is 14. So I started from back till 0. My end is I, which is the index. End is 6. My start is uh, one more one. So my end is 7. My start is 8 minus 7 plus 1, that is 8, which is 0. Fine. So start and end is correct. Now val is absolute value of I plus 1. I is 7 plus 1, that is 8. 8 minus place val, that is 7. 7 into 2, that is 14. 14. So we got 14 in the place value. Now if val is lesser than equals to k, now this val is lesser than equals to k, it is equals to k. So what I did is result of end is replaced with place val. Place val is 1, so this is replaced with 1, and result of start is replaced with 8 minus 1 minus 1, that is 0. So this is replaced with 8. Now place value changed to 2, and k minus is equals to val, so this will give me k is equals to 0. Now my end is 6. So this no no, there is something that I did wrong. Hmm, hmm, hmm. There is one mistake that I did. This one thing that I did wrong was I'm leaving that value as it is, but based on this I'm finding this, which I don't want. Just a minute, just give me a minute. I'm back. Okay, actually, we made it much more complicated. The only thing is changing the variable. Now, if this is changed, now suppose if I am not changing this, I want to change this. So 6 will be changed from this. 6 and 2 will be replaced and not 6 and 3. So for this, I need to do something. Mm. Uh, so this thing. this thing is this place value handling. I suppose if suppose I need to place 2 over here. So n is 8. 8 minus 2 minus 1, that will give me 1. So at place position 1 we are placing oh, okay, this is being handled. This is nothing wrong. Just want to know why for 8 and 14 we are getting. So for this we are getting 7 and 7, uh, which is 14, and value is lesser than equals to k. That's fine. So for result of end, we based on this I'm finding the start position, but based on place value, this value place value will tell me what should be the start position. If I'm placing 1 over here, my start is this. If 7 is fine. If I'm placing 2 over here, depending on 2, I want to have the start position. So that place value will decide. Place val minus 1. Why I'm getting so first it is 3 4, then 4 5, then 7 0, and after that I got 1 2 4. Okay. 8 14 1 1 2 trapeze. For this it is not possible, it's odd. For this 5 12 5 4 3 2 1. Why 5 twice? if it is 5 and 2, so 1 2 3 4. If I place 1 over here and 5 over here, so this will not, this will give me more. I need k is equals to 2. So I left this as it is. I left 5 as it is. For 4 also I left 4 as it is. For 3 I left a 3 as it is. For here my place value is still 1. My end of I, end is I, 0 1 2 3 4. So I plus 1, that is 2 minus 1, which will give me 1, into 2 will give me 2. So it is possible over here. Value is lesser than equals to k. Correct. So result of end is nothing but I. This will be replaced with place value, which is nothing but 1. And here here I need whatever value we have over this end. So place value minus 1 will have so for first it's yes 3 to 1. Second it's no. For third it's yes 1 2 3 4 5 6 7. For fourth it's no. For fifth it's yes 8 and 14. For second last 5 4 3 2 1. Let's check what is my k. K is 12. So 5 and 1 here, 5 here will give me what? 4 4 8. So 8 minus, so we are left with 4 more. Placing 2 over here and 4 over here will give me 2 and 2, which is 4. So minus 4 will give me 0. So we can place 3 over here. 5 4 3 2 1. It's correct. It's correct. Manhattan permutation. Let's try and submit it. Manhattan permutation. We got a wrong answer. Wrong answer. Manhattan value isn't equal to test case 306. Test case 306. Okay. If answer must be yes or no. uh, Equals to 2. अरे why don't you give me the test case? So it's 24. It's 2 and 4. N is 2 and K is 4. Obviously it will not be possible. So K For k is equals to 2 and 4, it's giving me just 2 and 1, but it should not, it's obviously no. But why it is giving me yes means I need to stop somewhere. I was thinking that this might give me some or other problem. So if 1 and 2, this is my 0 and 1, my place val is uh, 1, my end is I, so k is 4. For this I need to stop somewhere, so for k is 4, uh, I can place 1 over here, I plus 1, that is 2, 2 minus 1, that is 1, 1 into 2, that is 2. If 2 is lesser than equals to k, I can do that, right? So end is replaced with place value, and place value minus 1 is replaced with I plus 1, that is 2, right? Now my place value increased k, so place value is updated to 2 and k is left with 2 more. Now we came to at index 0. At index 0, what we found is I plus 1 is 1. 1 minus place value is 2, which will give me 1. Into 2, again it's 2, and it's equal to, so it will do again. Whatever happens, my I will be placed with a 2 and 0 plus 1, that is 1. So it's again 2 and 1, but okay, somewhere we need to stop. Somewhere we need to stop. We need to stop somewhere. Where? If suppose 1, 2, 3, 4, 5 and my k is 20, I can place 1 here, I can place 5 here. It's fine. So 4, 4, 8. 8 is removed, 12 left. I can place 2 over here, I can place 4 over here. So 2, 2, 4, now 8 left. Now my I've already filled till here. I cannot change now. I cannot go beyond this. I should not go beyond this. I need to stop. Means if my I goes lesser than place value, if it is even equals to place value, that is fine, because that is the place value that I want to check. But if my I or if my I is lesser than my place val, then also I should stop. see. It at least crossed. Okay, I accepted. So that was a mistake. That was the mistake. It should, if it goes lesser than place value, it should break from there. Okay, so finally, last time we were not able to solve this, but this time we were able to solve this by our own intuition. So it's great. It's this was a good question, and yeah, we somehow found the solution for this. So it's good. Now we can jump to next question, but before that, I'll take a 10 minutes of short break, and after that, I'll be back, and then we can solve more questions. We'll go for more questions. Okay, so I'll be back in 10 minutes. back. Okay, so let's start next. Why it went to mobile version? Now it's fine. Okay, so we were able to solve this one. Only one test case, because of one case we were facing problem. Now let's see this question and let's try to solve this. A snowflake graph is generated from two integer x and y, both greater than 1, as follows. Okay, though with the help of two integers we are able to generate a snowflake graph, both greater than 1, as follows. Start with one central vertex. Connect x new vertices to this central vertices. Connect y new vertices to each of these vertices. X is 5 and y is 3. So I have a central node. X is 5, 1, 2, 3, 4, 5. And for each node I have a y. I have three connected nodes. So this is a central vertex x5 and x is 5. X is 5 vertices attached to it. 3, 6, 3, 6, 7, 8, 20. And 3 y is equal to 3 vertices attached to each of those. Okay. So now the first line contains a single integer t that is ranging from 1 to 1000. The number of that's fine. What I need to do is, what should I do? What I have to do? I don't know. The first line of each test case contains two integer n and m. Okay, what is this n and m? N is ranging to 200. M is ranging from 1 to minimum of 1000, or n into n minus 1 by 2. Okay, the number of vertices and edges in the graph respectively. Number of vertices and number of edges. The next m lines contains two integers, each u and v. The number of vertices connected by an edge. The graph does not contain multiple edges and self-loop. It is guaranteed that the graph is a snowflake graph for some integer x and y, both greater than. Okay, so we need to find the x and the y. That's what he is saying. On a separate line output the values of x and y that in that order separated by space. Okay. So there are three test cases, as we can see, 1, 2 and 3. For each test cases it is compulsory that it will be a snowflake graph. Now I need to find x and y for this. So the first line contains m and n, n and m, n and m. This is n and this is m. That is 21 and 20. Okay. The next m lines, next 20 lines from here till here. Each contains two integer u and v, u and v, u and v. The number of vertices connected by an edge. The first test case is pictured in the statement. Note that the output 3, 5 is incorrect since x should be output before y. Okay, first test case का graph we have. So see, so we need to find something which is very repetitive things over here. So we have to find repetitive things over here. So we can see 20 20 20 3 3 3 8 8 8 7 7 7 6 6 6. So 1 2 3 4 5 5 are 5. There are 5 things which are repeated thrice. 5 items which are repeated thrice, and there is one item which is repeated 5 times. So x can be 5 and y will be 3 for this case, right? Now let's see in the second case how to go with the graph and iterate the graph. Let's understand. So n is 7 and m is 6. So there are 6 edges, and there will be obviously one more node. So 1 1 2 2 3 3 is there are 3 times repeated. 2 repetitive things has occurred thrice, and so maybe we should not create graph over here. Maybe we can directly predict it from 1 to 2. We have 1 2 3, we have 2 to 4, we have 2 to 5, we have 3 to 6, we have 3 to 7, we have. So 1 is the central node. And 2 x is 2 and y is also 2. So 1 is the central node, x is 2 and y is 2. In the third example, we have 9 and 8, n and m. There is an edge between 9 and 3 and 9. How many nodes are connected with 3? For every so from 3 I can see 6 is also connected. Anything else? 4 is also connected. Anything else? 8 is also connected. So I can see this node has a maximum connection. if central node is 1, y is something like this. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this can also be case where 5 5 times like from 2 is connected to 5 nodes, 3 is connected to 5 nodes. So I need to find something from here. One is connected to node 2 nodes, 2 is connected to 5 nodes, 3 is also connected to 5 nodes. Now the one who is connected to single nodes, uh, I'll sort it in order. Okay, and it's saying that it will be always a snowflake, so I don't have to uh, make any other guesses. So something like that. So 4 is connected with one node, 5 with 1, 6 with 1, 7 with 1, 8 with 1, 9 with 1, 10 with 1, 11 with 1, 12 with 1, and 13 with 1. So let's sort it based on this how many nodes they are connected to. So uh, 2 is connected to 5 nodes, 3 is connected to 5 nodes, one is connected to two nodes. So how many nodes are there? And from the position 1, I suppose that will not matter. In only one case it will matter. Let's see. Just a minute. Just a minute. I'm getting a call. Okay. So I need x and y. I don't care about the central node. I need the largest and the second largest. So in this case, x will be my 2, the smaller one, and y will be my 5. And in opposite case, if if 1, 2, 3, 4, 5, 6, and everyone is connected with one node, 7, 8, 9, 11. So in this case, 1 will have 5 connections. I have 6 connections, not 5. 2 will have 2 connection, 3 will have 2 connection, 4 will have 2 connection, 5 will have 2 connection, 6 will have 2 connection. Now from 7 onwards, 7 will have 1, 8 will have 1, 9 will have 1, 10 will have 1. So there will be only 3 values. Now based on that, I need to judge which one is x, which one is y, and which one is central node. Because if it is only a snowflake graph, then there must be something. Okay, what can we think of? What can we think of? Now 1 is connected to 5 node. Now in this case 1 is not my x. My x is 2 3 4 5 6 total count. So okay. How many 5 frequencies are there? 1. How many 2 frequencies are there? 5. How many 1 frequencies are there? 4. So in this case do we need to know 10 11? Don't you think this will always come out to be same? This 1 and 5. I only need, so these two will become my x and y. In this case how many were having a frequency of 2? 1. Frequency of 5 we had 2, and frequency of 1 1 2 3 4 5 6 7 8 9 10. So see, in this case anyone can be x and y, but in this case this should be x and this should be y, because if we are making 10 means the one who is equal to or greater than the previous value should be my y, means the largest value, the largest will be my y, the second largest will be my x, and the third largest is my central node. Is equals to central node. This is what I concluded. I suppose this this should be what the actual conclusion. Let's try and see with all the 3 cases. Because y will always be at least equal to x, and x will always be equal to central node or more than that. This is the thing. So central node is should be lesser than or equals to my x, and x should uh, be lesser than or equals to my y. Y can be greater than or equal to x. X can be greater than or equals to central node, and central node can be. So this is the pattern that we got. So for the second case, 7 and 6. Now one, let's draw the graph and see. 1 is connected to 2, 1 is connected to 3, 1 is connected to 2, 1 is connected to 2, 3, 2 is connected to 4, 2 is connected to 5, 3 is connected to 6, 3 is connected to 7. Okay, so 1 has a frequency of 2, 2 has a frequency of 2, 3 has a frequency of 2, 4 has a frequency of 1, 5 has a frequency of 1, 6 has a frequency of 1, 7 has a frequency of 1. Now there is something I need to handle, the case for central node. So out of these, one frequency is 4, two's frequency is 3, and there is no more frequency. So that in this case I need to separate out something. What will be separated out is central node will always be 1, will always be 1. So the second largest node, from that I will extract central node and I reduce it to 2. So the my x will be 2 and my y will be 4. Now x is 2, y, we know y is total number of nodes, so y will be total 4 divided by 2, which is nothing but 2. So actual y is 2, x is 2 in this case. Okay, now for the third case, let's go for the third case. 9 is connected with 3, 9 is connected with 3, 3 is connected with 6, 6 is connected with 2, 2 is connected with 1, 5 is connected with 2, 2 is connected with 7, 4 is connected with 3, and 3 is connected with 8. Something, this is central, this is x, and rest are y. So let's see. Now 6 is connected with 2, 3 is connected with 3, 2 is connected with 3, no, not 3, 3 is connected with 4, 2 is connected with 4, 6 is connected with 2, right? And now 4 is connected with 1, 5 is connected with 1 is connected with 1, 7 is connected with 1, 8 is connected with 1, 9 is connected with 1. So total frequency of 1 is 6, total frequency of 4 is twice, and total frequency of 2 is 1. So I know my x is this, my y is this. Y will be what? Y is not exactly this, will be 6 divided by 2, which is nothing but 3. So y is equals to 3, x is equals to 2. So x is 2, y is 3. Suppose this should be the solution this way. The only thing is, if there are two frequencies, I need to reduce from the lowest one. I need to take one out. Forever winter. Now taking input is something problematic over here. I will be having two things, N and M. First scene N and scene M. Now the loop will run M times. And I need to store it somewhere. It's the edges or vertices. So I is lesser than I. There will be M edges, but the values are not defined, right? That's what I can see. If there are 21 vertices and 20 edges between all of them, so it will always be in a range. Okay, use values lesser than equal. U and V's values are lesser than equals to N. That is what it's saying, and U and V are not same. So it will be lesser than equals to N. So we can create a so the row size will be 20. Okay, even we are getting this directly. Why to create a vector? I don't know, unordered map. Uh, C in U, C in V. Map of U plus plus. Map of V. Map of U plus plus. Map of V plus plus. That means that values frequency. How many times um, we have seen that values frequency. That will be there. Fine. Now after this I need to solve it. So solve will always print something. So after giving this solve a map, I can place a endl. Solve will receive this inside. Now here I'll have to create another map, a frequency map. Frequency map will be nothing. Map dot begin while it is not equals to map dot end. Frequency of it का second plus plus. Okay, this is what we were doing, right? 6 has a 6 is connected to 2 node, 3 is connected to 4, 2 is connected to 4, 4 is connected to 1, and this. And now 2's frequency is 1, 4 frequency is twice, and one's frequency is 6. Now this and this are calculated. Now auto IT1 will be my second map, which is create a vector answer. Auto it1 is equals to frequency dot begin while t1 is not equals to answer dot sort now if answer dot size is equal to 2, so then what I need to do is answer of 0 minus minus. I need to take off one value which will be my root. So my x is nothing but cout answer 0 and y is nothing but, just a second, cout answer 0 and cout answer 1 divided by answer 0. If that's not the case, we'll go in else. Everything everything will be same. Instead of 0 it will be 1 and it will be 2 and it will be 1. Now let's pick up. For first it's 5 3 2 2 and 2 3. Let's try to what's the value, what is the value? Forever winter. Thanks. So it got accepted. The only thing which we needed to be careful of was this if answer that size is 2. So in that case only we needed to do one thing, is reduce the value for the root, and for the rest it was fine. So this was not that difficult. So we were able to solve this Manhattan permutation also for the winter also. Let's go to arrow path. This looks nice. Let's understand the question. So there is a grid consisting of two rows and n columns. Two row and n column. Okay. The rows are numbered from 1 to 2 from top to bottom. The columns are numbered from 1 to n from left to right. Each cell of the grid contains an arrow pointing either to left or to right. No arrow points outside the grid. Acha, okay. There is a robot that starts in the cell 1 1. Every second the following two actions happen after one after another. Firstly, the robot moves left, right, down or up. It can't try to go outside the grid and can't skip a move. Then it moves along the arrow that is placed in the current cell, the cell it ends up after its move. Firstly, the robot moves up, left, down. So it can move in all the direction. It can try to go outside the grid. It can't try to go outside the grid and can't skip a move. Okay. Then it moves along the arrow that is placed in the current cell. Then it moves along the arrow that is placed in the cell it ends up after its move. The task is to determine whether the robot can reach the cell 2, n. That is the right, bottom right, right, bottom right. Okay, the first line, second line, the first line, second line contains a string consisting of exactly n characters, lesser than and or greater than or empty. The first row grid. The third line contains a string consisting of exactly n characters. This the second row of grid. This is the first row of grid. This is the second row of grid. It's fine. These are the two row of the grids. Note in the first example, one of the possible path looks as follows. I just need to tell yes or no. So what's this arrow? What's the meaning of this arrow? So no arrow points outside the grid. So that means the last arrows are fixed. These two arrows are fixed. Uh, there is a robot that starts in cell 1, 1. Every second the following action happens one after another. Firstly, the robot moves left, right, down or up. It can't go outside the grid and can't skip move. Then it moves along the arrow that is placed in the current cell. If the cell it ends up after its move. So in the third case it's no. Let's check the third case. Why? There is no way to reach cell 24. One 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 two. Why can I go to 1 3? Why I will go to 1 3 in the first example? 1 3 has an arrow of backward sign. Mm. Okay, let's understand this. Let's take a 10-minute break, and when we'll be back, let's try and understand this in a better way by dry running this, and then we'll be solving this question. So it will not be difficult if we understood this part. So we'll be back in 10 minutes. Don't go anywhere. We'll be back soon. I'm back. Let's solve this. Okay. Status. I don't want status. So, so where were we? So we had a robot which is at cell 1 comma 1 in a grid of row 2. Now every row, firstly the robot moves left, right, down or up. Every second the following two actions happen, one after another. Okay, one after another these two actions will happen. So first action will, the robot can move right, left, top, down, anywhere, and then it moves along the arrow that is placed in the current cell. Okay, so the first cell will always have a direction of this, and the last cell, these all will have a direction of this. These are fixed. Now robot is here. The first thing that he will do at every place, firstly the robot moves left, right, down or up. Then it moves along the arrow that is placed in the current cell. Okay, the cell it ends up after its move. Okay, so in first move, okay, now we are getting somewhere. Let's look at this. So my robot is here, I am here. If I do a move of moving right, so I am at this position. Now this cell, this arrow will say move again right, so I'll reach here. Anyway, I'll reach here. Whether it is left arrow, right arrow, doesn't matter, but I'll reach here. Now from here I can decide, I can go backward, I can go down, I can go right, I can go up. So if I go down, I'll reach here. If I this arrow says go right, I'll reach here. Simple. Now in the case where I will not be able to reach, let's see that. So we are given like this: 1, 2, 3 and a back, 1, 2 and back, right? So I am positioned over here. I do a right move, I'll move here. I do a down move, I'll move here. I do a right move, I move back here. I do a down move from here, I go back here. I do a right move here, I go back here. So in any way, in no way I'll be able to reach here. Hmm. I can I can even do a upward call also. So suppose the boundaries will always deflect me back. The boundaries, I cannot go to this boundary because it will always deflect me back. What option do I have? This arrow, at any cost, this arrow should be a right arrow. Then only I'll be able to reach here. At any cost. If this is not a right arrow, a right arrow, not possible. Not possible. This needs to be a right arrow. Why? Let's take a single cell example. Single cell cannot happen. At least two cell will be there. So suppose one cell is this and this. So from here, if I go here, I'll go back here. From here, if I go here, I can go here. So I can reach. So in two, if cell size is 2, I'm 100% sure that I'll reach, because these are boundaries and these arrows are fixed. Now comes when we have 3. They will be fixed. Now this position needs to be this arrow. If I'm doing this arrow, if I'm doing this arrow, I only have 2 arrows, right? So if even this is this, so I'll reach here. Hey, but I can, right? No, no, no. In this case also I can't. From here, if I go here, this will push me here. Fine. From here I can. If I go here, this will push me back here. I cannot stay here. Just a second. For 2, for 2, it's always yes. It's always yes. It's possible. I go down. From here I push here. I'll be pushed here. I'll stand here. From here if I go right, I'll be pushed here. From here if I go down, I'll be pushed back here. In no case I'm standing over here in any place. If this arrow is a left arrow, if this arrow is a right arrow, I can do anywhere. I can go bottom. I'll be pushed here. From here, No, just a second. Just a second. There is this arrow. From here to bottom, I'll be pushed here. I'm standing here. From here, if I go right, I can reach. I'm not getting pushed back. This, this is what is it's saying. I'm not getting pushed back from here. From here, if I go here, from here I can go here. I'm not getting pushed back. I can stay here. That's what the question is allowing me. Will it? Is it? Is the question allowing me this? Allowing me this? Are you sure? No. No, the question is not allowing me this to do this. From here I get here. From here, if I go here, I'll go back here. So from here, if I go, I can go here. From here, if I go here, I'll go back here. There's two move always happening. And after this two move, I need to check whether I'm reaching to an or not. Right. So in any case, I need this arrow to be a right arrow. I can do recursive calls for this. Recursion can be one of the solution for this. By doing recursion, I'll be able to solve. But I'm trying not to solve this with recursion. I want to solve it with something else. Means it's saying I can skip one arrow. And the arrow where I'm standing, I can skip that. For the last one, if this arrow is a lesser than arrow, what will happen? From here, if I go here, in any case, I am depending on something. I am depending on something. If you see, for 4 and 5 together, there is something that is happening. See, I cannot stay at one position. I need to move. I need to move. Either I can go right, I can go left, I can go top, I can go bottom. Right. So this arrow will be this. Now I depend on this box. I depend on this box position. This box. I somehow need to reach to this box with a move. Either I can come from here or I can come from here, and this should be a right arrow which will take me to here. So if I am coming from here, that means I don't care about this box. I don't care about this box arrow. Whether it is left or right, I don't care about this box's arrow. I care about this box arrow, this box arrow, no, not this box arrow, this box arrow and this box arrow. No, even I'm at this position, I don't care about this box's arrow. If I reach over here, I do a move and I reach here. If I reach over here, I do a move and I reach over. No, I do a move, then I reach here. I do a move, I do a move, and then I reach here. So from here, I do a move, and then I reach here. So this box value is not important to me. This box's value is not important to me. Right. What important to me is how I am reaching here and here. Because if we are reaching here and here, that will decide, that will be my decision. So from if I'm reaching here, I need to have this to be this arrow. To reach here, I need to have this to be a right arrow, or to reach here, I need to have this to be a right arrow. Because if when I reached here or reach here, this arrow will directly shift me here. This arrow will directly shift me here. I can solve it with recursion, but I don't want. I need to understand more logics. I can do DPN memoization. It's not a problem. This can be solved with those techniques. But see, uh, these two moves are done together. Now this box needs to be a right tick, right arrow. That's fine. Now I need to reach here, I need to reach here. I have to reach here, I have to reach here. These are my destinations. From here I can move here, and this will place me here. From here I can move here, and this will place me here, right? So to reach here, to finally reach here, I need to have someone pushing me here, pushing me here, pushing me here. Side. So if I have a right arrow over here, this will push me directly to this position. I need a right arrow over here also. This will push me directly to this position. I don't care about the arrows at this position. I need a right arrow at these positions. So these positions will say something. Let me make it more bigger. So these positions will say something to me, that this will shift me here, this will shift me here, right? To come to here, I need to stand here, or to come to here I need to stand here. I don't care about arrows of these two places, but I do care about arrows of these two places. So if I'm standing here, I do a right and I move here, and from here I do a bottom, I move here. From here I do a right, I move here. From here I do right, I move here. When I do a up, I move here. Now to reach at these positions, this position, what I need a arrow, a right arrow over here, a right arrow over here. I reach to this position. So it might be possible that this is a lesser than sign. So I do this move, I reach here. 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 So it's not a compulsion, but I need true from any of these. So like to reach this position, from where I can reach? I can only reach from here. So if this is a right arrow, this is true. I can reach over here. Even from bottom I can go here. It doesn't matter. But this needs to be true. So this, if this is true, if this is true, this is true. If this is true, I don't care about these two places. I care about these two places. So if this is a right arrow, or this is a right arrow, this is true, then true. Based on this, if there is a right arrow over here, I can place true over here. If there is a right arrow over here also, I can place true over here. So for these two are places, because I'm shifting now. Suppose this is not a right arrow. There is a problem, and this is a, sorry, this is a left arrow. Now what? Okay. If this is a right arrow, this will be true. If this is a right arrow, this will be true. Else, this will be false. Now to move here, I need, I reached here. I moved right. I reached here. Well, again, that is of no use. So this path is false. This path is never going to take me. I'll reach here. Again, okay. I reach here. I'm getting a little confused with which one to follow. I care about these arrows. This will place me here. This will place me here. If this is a right arrow, then true. If it is a left arrow, then false. Because of this, I will never be able to reach here. Now I didn't care about these two positions. Care about these two positions. So now if this is false, I can say I cannot this path will never push me forward. So this is false. Now to reach here, I have two way. If this is a right arrow, I'll go here. Okay. So instead of going from back, let's try to go from front. Maybe that will give us some idea. So if I'm this will be, so if I'm at this place, I can reach to this place. I can reach to this place. To reach this should be a right arrow. Okay, so initially this is true and everything is false. Suppose false, false. Rest everything is false. So now to reach at this place, is it possible to reach this place? No, it's not possible to reach this place. So we can never reach this 0 1 place. This will always be false. Can we reach this place? No, this will always be false. So we can reach this place or this place depending on the arrow. So if we are reaching this place, it depends on this arrow. If we are reaching this place, it depends on this arrow. If this is the right arrow, I can reach here. So if I can reach here, if this is true, this, and this is the right arrow, this is true. If this is true, this is the right arrow, this is true. Now I am at these two positions. So these were right arrow, suppose. Now this is the left arrow. If this is the left arrow, if this is true, this is the right arrow, then I can reach this. If this is the left arrow, I cannot reach here. Now from here, what places can I reach? I can reach here. I can reach here. From here, I can reach here and here and here. From here, I can reach here and here. So from here, if I have to reach here, I need to have this as a right arrow. If this is true and this is a right arrow, I can reach here. No, I cannot reach here. If this is true and this is a right arrow, I can reach here. And if this is a left arrow, I cannot reach here. So this will be false. So from here, I cannot reach here because this is a left arrow. So this will be false. In both cases, this became false. Means I don't care about these two places. See? So from here, if I see these, if I want to reach here, I don't care about this. Maybe this is the So from here I can take this arrow and go here. So from here I have two places. I can reach here, I can reach here, depending on this between arrows. So if this is true and this is the right arrow, I can reach here. If this is true and this is the right arrow, I can reach here. From here I can reach here, or I can reach here. So if this is true and this is a right arrow, I can reach here. True kar do. If this is true, this is the right arrow, I can reach here. So from anywhere I reach here, from here it will push me back here, from here it will push me back here. So if I can see if there is two cross left arrow, no, if this is a two cross left arrows and these are right arrows, I can cross these two. I can cross these two. That means I need to check if they are even this, like this. From here I reach here. From here here I'll go back. From here I'll go back. Means in any case, if odd, at odd and even place, starting from odd and then even, if they are in opposite. Now let's try with the test cases, more of a test cases. Let me remove the white screen, erase it. And in the no case, is this what happened? No, if I take this case 1 2 3 4 5 6, 2 3 4 5 and 6. Now 0 1 2 3, sorry, 0 1 2 3. So now you see one and this, no, this and this, no. And this should be, this last arrow should be a right arrow. So it's true, it will return this arrow, this arrow, this arrow, this arrow, this. So 1 and 2. No. This and this. No. Let's try with this. Let's go with this. Odd indices arrow. If both arrows are opposite in this direction, will not be able to go. That's what my intuition is going. Okay, what should I take as input? Now I have int n. Now what we are taking is a string. I think contains a string consisting of exactly n characters. So it's a string str. Maybe row 1 or first row, second row, first row, second row. Okay, and can I print the string directly? C out, first row, second row, and L. Yes, okay, fine then. I need here only. I'll check if second row of n is 4, 0 1 2 3. It's n minus 2 is equal to this arrow. So see out. No. solve and return a string. Now if arrow is 2, so it will be something like this. So if this is a right arrow, if size is 2, it's fine. If size is 3, then 0, 0, 1, 2. So 1 and 2. If size is 3 also, then also we are not checking, will not be checking. If size is 4, so then these two values will be checked. If size is 5, then these two value here. There's something fishy on odd size. From here, if all are right arrow, suppose every path I can go. So from here I can go here. This will push me here. From here, if I go here, this will push me here. And if it is a left arrow, it doesn't make sense. So if I can go here. From here I can if I have a right arrow, I'll go here. From here, if I go to top, I have a right arrow, I can go here. From here, if I have a right arrow, I can go here. From here, if I have a right arrow, I can go here. Here. But if I reach any of these two places, won't be making sense. I will not. So if odd size, I cannot reach. Or n modulo 2 is equals to 1. And in even size, when we have 2, 3, 4, so it will be even size, that means 1 2 3 4 5 6 6. So I need to compare these two, then these two. If it was 4, these two, it was 2, if it is size of 2, um, if it is size of 2, I will always reach. If n is equals to 2, I will start from 1, I is lesser than 4. 4 size, it means 0 1 2 3. If first row of I is equals to this arrow, and second row of I is also equals to this arrow, then I'll simply return no. No, yes, no, no. Why? Oh. Yes, yes, no, yes. This is what we wanted. Yes, yes, no, yes. Let us see if I choose a file. What's the name? Arrow path. Arrow path. See if I get a wrong answer. Hmm. Fourth token. If times is 50, if it's equals to 53. I wanted this to be simple. So the arrow is this. Wrong output format. Yes or no expected, but okay, fine. A triple arrow. Tricky, huh? So what actual answer is? Wrong answer. Expected no found. Yes. Oh, okay. I cannot reach. And I found a yes. Let us see. From here, it's an even size. So this side is also being blocked. This side is also being blocked. If this is also being blocked, I won't be able to do it. This is also being blocked. If this is blocked or this is blocked, path is blocked. So 1 and 2 means 0 1 1 and 2, and then in next block this and this, then in next block this. Size is 2, then it's fine. If size is 3, no, if it's 4, then this and this or this and this. start from 0. Yes, yes, no, yes, no. So now it is accepted. So this question was like I could have made it using what should I say, recursive approach, but I was thinking of implementing some other logic, better logic, and this is way better logic than anything else. So even I can like shift this here. So instead of I plus 1, it will be I, and this will be I minus 1. Arrow path. Accepted. So instead of going for 2 for loops, I can directly go to 1 for loop, and this is a simple condition. It was just a confusing type of question, but was not really that implement powerful. I have just so this was kind of nice question. Was mm, we can also try this question with recursive and memoization approach, but this is way better than those recursive and memoization, because it's iterative and O of n time, even not n time, it's O of n by 2 times, nearly n only, but it's n by 2, so it's simple. So there were few things that I needed to remember in this. Is if the second row's last, second last value is if it is lesser than, then directly no, it's not possible. And if it is a odd, and then also it's not possible. That was the this was the conclusion that I found when I I almost completed my solution, and then I got to know that okay, if it is odd, we won't be able to reach, because we are always shifting one place after. So if we are at one place, if we are going to the next place, we always shift from there, always slide from there. We are not standing over there. So if it is odd, we won't be able to reach. Never, we will never reach a position where we want that the it should stay. The robot should stay over there and not move. And that we are not 100%. Will not make sure in that case that we are reaching the last element. So that's why we checked it with odd also. If it is odd, we printed no. Else we tried to find some way. So in that case, we found the first row I and the second row I. If there is some continuous way where we are getting opposite arrow, then we'll stop over there. So if there is some continuous way, if we see there is one continuous way where we are getting a left arrow, so in this case we'll stop. If there is if there is any continuous way we are where we are getting right arrow, left arrow, like this and this, if these are left, then also we won't be able to make it. Or if this is the case, then also we won't be able to make it. So in both the cases we won't be able to make it. So for these cases only we applied two conditions, and everything went well. So yeah, this was the solution for this. It was nice small trick hidden in this question. Okay, so it's almost 2. I'll have to have my lunch. Let me have my lunch, and when I'll be back, we'll start with few more questions. So maybe I'll make it a shorter break this time. Long break. Let's take it for 40 minutes. And I'll be back after that, and then we'll be solving more questions after having my lunch. Okay, see you after lunch break. Hello, I'm back. I'm sorry I'm late. I know I'm late a lot, but I'm back. I got busy some work with some work. Uh, Snowflake. We did solve a snowflake question that was forever winter. Ah, okay. This is a Rudolph and Snowflake simple version. Let's start. This is Rudolph and Snowflake simpler version. Okay, let's go. So it is saying this is a simple version of the problem. The only difference is that in this version n is lesser than or equals to 10 to the power 6. A certain symmetry in the configuration of the software, and like a true mathematician, Rudolph came up with a mathematical model of a snowflake. He defined a snowflake as an undirected graph constructed according to the following rules. Initially, the graph has only one vertex. Okay, then more vertex are added to the graph. The initial vertex is connected by edges to k new vertices. K is greater than 1. In the initial vertex is connected by edges to k new vertices. Okay, each vertex that is connected to only one other vertex is connected by edges to k more new vertices. Each vertex that is connected to only one other vertex is connected by edges to k more new vertices. This step should be done at least once. Okay, let's understand the second point much more clearly. It is saying each vertex that is connected to only one other vertex is connected by edges to k more new vertices. The smallest possible snowflake for k is equal to 4 is in the figure. So initially it is one vertex, then more vertices are added to the graph. The initial vertex is connected by edges to k new vertices. Each vertex that is connected to only one other vertex is connected by k more new vertices. So each is connected with k more new vertices. Okay. The smallest possible snowflake for k is equals to 4 is shown in figure. Okay, so this step should be done at least once. That means central node is connected with k nodes, and step 1 is every other node is connected with k node. After some mathematical research, Dolph realized that such snowflake may not have any such snowflakes may not have any number of vertices. Help Rudolph check if a snowflake with n vertices can exist. Acha, okay. The following description, then follow the description of the test. The first line of each test case contains an integer n, that is 1 to 10 to the power. The number of vertices for which it is necessary to check the existence of a snowflake. So 1, 2, 3, 4, fifth test case. 1, 2, 3. 13. 1, 2, 3, 4. So can there be snowflake with n vertices? So like can there be snowflake with 13 vertices? That's what he is asking me. So I have a central node, so now left with 12 more vertices. So if I connect 4, so 8 more left. So if I suppose if I'm taking k as 1, I'm not getting the answer. K is okay, k should be greater than 1. Then more vertices are added to the graph. The initial vertex is connected by edges to k new vertices. So if k is 2, so initially vertex is k is 2, so 2 more vertices connected. So 12 minus 2, that is 10 new added. So in this 2 more will be connected, 2 more will be connected, 4 more gone, 6 left. 2 to 4. Now 2 more will be connected to each. 3, 4, 5, 6, 7, 8. No. If k is for the smallest possible snowflake we are taking is this. If k is 4, that means what? How many vertices do we have? 1 2 3 4 5 6 चार 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 बारह 16 16 20 एक 21 for 21 node. If 21 nodes are there, then k we are taking as 4, in which we are leaving one for central nodes. If k is 2, sixth, 7th, 15, for which it is necessary to check existence of a snowflake. So if n is 15 means एक नोड तो सेंटर नोड है, तो 14 बच रहे हैं. 14 नोड में अगर हम दो का बनाते हैं, k is equals to 2. Are we considering this? One, two. Now this has two more. One, two, three, four, five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So k is equals to 15 possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So n is if n is 15, then k 2 is a possibility. If n is 13, then how it is a possible condition? 1, 2, 3, 4, 5th. 1, 2, 3, 4, 5. Fifth is yes. If total number of node is 13, then how we are making it possible? One, two, three, four, five, six, 7. If I connect only one node, but k should be at least each of which is the answer of the corresponding. Yes, if there exists such k greater than 1, for which snowflake with the given number of vertices can be constructed. Otherwise no. So k should be more than 1. So the minimum k is 2. The minimum k that we can take is 2. So k 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4. Fifth test case 1, 2, 3, 4 is 13. 13, I have a central node as 0. I can connect a minimum of 2 nodes to this central node, that is 1 and 2. Why its answer is yes? I'm not getting this. Can any one of you explain this? Why its answer is yes? For 13, if k value, if we change the k value, what will be? If we add 2 more k's, or are we missing something from the question? 3, 4, 5, 6. Now if we add 2 more to this, 2 more to this, 2 more to this, 2 more to this, it will not be possible. Should it be symmetrical? Means if 13 can be possible in only case when 3, 6, 7, 8, 9, 10, 11, 12 and 13. If I don't add any edge to this k, like k is 2, so I'll have to add 2 over here, but if I don't, then 13 is possible. Then 13 is a possibility. Now similarly, if I remove 2, 11 is also a possibility. 9 is also a possibility if I remove this. 7 is also a possibility if I do it in this way. If I have 21 nodes, I saw that k is equals to for 4. If I have 21 nodes, if I add, so it's 15 now. 16, 17, 18, 19, 20, 21. I can. With k is equals to 2 also, I can make any of the numbers. It will always go 7, 10, 9, 8, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21. Are we saying that all the odd numbers are possible? 3 possible. Minimum 3. But this step should be done at least once. Each vertex that is connected to only one other vertex is connected by edges to k more new vertices. Means I can start from 1, 2, 3, 4, 5, 6, 7. 7 is the bare minimum that I need. 7 is the bare minimum that I need. If it is lesser than that, I'm not doing it. 7 is the minimum that I need. After this, if it is odd, possible, even, not possible. And if it is lesser than 7, also not possible. And what I think is this is the possibility. This is odd, this is odd, this is odd, this is odd. So it's possible. 6 was not possible, 3 is not possible, 2 is not possible, 1 is not possible, because they are lesser than 7. At least we need one. Maybe this will work. Maybe. Let's see. Okay, so we are given n and c in n. Now if n is lesser than or 7, bare minimum which I need is 7. So c out no, and else if n modulo 2 is equals to 1. If it is even, sorry, I can add these both conditions. So n modulo 2 is equals to even. Let's see. Oh, okay. So it's no for 4 of the test cases. 5 because these were odds. So yes, and for last it's no. Let's see if our concept is wrong or right. Rudolph SV. If we are right or wrong, are we right or wrong? Wrong. Wrong answer expected, no, found yes on the 9th token. 9th token तो देख सकते हैं 1 2 3 4 5 6 7 8 9 which is 9. For 9 expected no but found yes. अच्छा so n is equals to 9, expected is no. Why? 0 1 2 3 4 total 5 6 7 8 9. We make something like this. But if for this it is no, then why for 13 it's yes? Even if we do 3 1 4 4 8 4 12. Oh, okay, for 3 it's working, right? 1 2 3. If we take k as 3, then 13 can be done. 13 is possible. Like 1 2 3 0 1 2 3 4 5 6 7 8 9 10 11 12. So we need all the edges. We cannot skip all the edges. Okay. So now I think I understood the whole logic behind this. So now we can So if k is 3, then n is 13 can be a possibility. Now k, if k is 2, and then it will go for odd. 0 1 1 2 3 4 5 6. So 7 is the minimum from where I can start. If k is 2, then 7 is the minimum from where I can start. If k is 3, 13 is the minimum from where I can start. If k is 4, 21 is the minimum from where I can start. If k is 4, 21 is the minimum from where I can start. So now okay, just a minute, I'll be back in a minute. I'm back. Sorry, sorry. Okay. So where were we? Huh. So uh, if it is 21, if k is suppose 2, so we were always basic base start is 7, and then if 2, it'll go something exponentially or something progressively. So if we add 2 more, 15, so after it will be 15 somewhat, 15 15 over here, and then we add 2 2 2 again, will be 31. Maybe it's going 7 into 2 plus 1, then 15 into 2 plus 1, and then 31 into 2 plus 1, because 2 more nodes are added. For those 8 nodes, 8 into 2. So for these 1 2 3 4 5 6 7 8, for these 8 nodes, 16 nodes more will be added, which will give me 13. So for these 16 nodes, 32 more nodes will be added, which will nothing, it will give me 63, which is nothing but 31 into 2 is 62 plus 1, that is 63. If k was 2, that means n into 2 plus 1 is their total number of total nodes. Now if k is 3, 1 2 3 4 5 6 7 8 9, so for each node 3 more node will be added. So 1 2 3 4 5 6 7 8 9, currently it's 15, right? 10 11 12 13, 9 10 11 12 13. So this is 13, sorry, not 15, this is 13. So bare minimum what we require is 13. Now for last node 1 2 3 4 5 6 7, for last 9 nodes, 3 more nodes will be added to each, so 27 will be added to each, which is nothing but 40, which is same, 13 into 2 plus 1, which is 27. And the minimum number of nodes that we require, suppose k is 3, so minimum number of node that we need for k is equals to 3 is 1 2 3 3 into 3. So 4 means n plus 1, sorry, not n, k plus 1, that is nothing but 4 4 plus 4 plus k into k means k plus 1 plus k square. This is the minimum that we require. So 4 plus 3 9, 9 plus 4, that is 13 if k is 3. If k is 2, 3 plus, that is 7. 7 number of nodes is required minimum if we are taking this, and then it will go same, n into 2 plus 1. So if we see this 255, if we compare this to 55, what we will get? So this 255 we can do if we are taking k. It will be something like 255 is equals to n into 2 plus 1. So 255 minus 1 will be give me 254, divided by 2 is 127. So n is 127. This is the minimum. And now k plus 1 plus k square is equals to 127. If this gives me an integer value, then k square plus k minus 126. If I will be able to solve this quadratic equation, now for 13, if I check n into 2 plus 1, which is nothing but 6, n is equals to 6. K square plus k minus 5. or k square plus minus 254. We are getting to some mathematical formula, but okay, let's do it. If k is 4, the minimum number of nodes that we require is 21. Now, for every node, every last node, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. For every last node, that is 16, 4 more nodes will be added. That is nothing but 16 into 64, 85, total 85 nodes will be there if it is new node. Okay, there is some problem. So from n is 21. Next time if we add, we'll be adding 4 to each and every node, which gives me 64. And total will be 85. So from 21 to 85 is nothing but 21 into 4 plus 1. 4 and 4 to the 8, 84 plus 1, which is 85. So n into k plus 1. N is nothing but the previous node, previous number of nodes times k, and adding 1 to it will give me 81. That's the first equation that we can see. So if we know n, if we know n, we will be able to find k. And if it is possible, if I add 21 over here, k plus 1, which gives me 81, is 80. Sorry, it's 85. So it will be 84. So k is 4. So we got something, n into k plus 1 should be my like 255 or something, but I need to know the base. Sick. n can vary. Now n can be multiple of any yeah, n can be multiple. K can also be multiple. 255 10101. Oh, this is some basic. If total number of node is 21, will it possible? I need to find some value of k for which this satisfies. I need to find something else also. The base, if k is 4, what's the base times it's like k plus 1 5 plus k into k. K plus 1 plus k square is equals to base. That's the minimum, bare minimum that we need if k is that. For 21 the next is 85. Now 85 will have what into 4 plus 1, so 3, it's 325. Now if n is 325, how I will get to know that there is a k 4 exist for which this is possible? If consider this as the basic, like base, if 85 is the base, will it be possible? I don't think it will be possible. Is if I equate it with 85, what it will be? No, 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 no. This is something. I need some extraction from here. If n is 10 to the power 6, should I iterate? I'm not getting any clue. How we will get to know like the previous value? Now, if suppose n into n is 21, k is 4 plus 1. If I multiply it by twice, what we will get? This will give me 85. Let's see the tutorial for this. This is the first question whose tutorial we are watching. I'm not sure it's something. Maybe let's see what if the nail with the rope is the only one. What does that mean? What if the nail with the rope is the only one? I'm sure this is not. Okay, it's yes, exactly. It is going something like that. 1 plus k square plus k to the power q plus dot 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 k to the power p, something which giving me 325. If k is 4, so if I do this, what will happen? 16 plus 4 plus 1, which is nothing but 21. plus 64 is nothing but 85, right? So it's very much going to like k 1 plus k square plus k cube plus k to the power k is equals to that value. Now how to there is some mathematics. I forgot all the maths that I learned. Nice. 1 plus k square plus k cube to the k to the power p. What will it be? Power. I should do 1 plus k 1 plus n square plus n cube plus dot formula. What are you showing me? No, not 1 to the power n. Is equals to n to the power n plus 1 minus n divided by n minus 1. ऐसा है क्या? Or is it n into n plus 1 minus n by n minus 1? N is nothing but k over here. So k, if I take 4, n is nothing 1 1 2 3 1 2 3 4 1 2 3 3 to the power 3 plus 1 3. this. N to the power m plus 1 minus n minus m. So n to the power 1 plus n to the power 2 plus n to the power 3 plus dot 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 n to the power m, something like this. So 1 plus geometric progression 1 plus k square plus k means k to the power 0 plus k to the power 1 k to the power 2 k to the power 3 dot 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 k to the power p is equals to some value. Now it will be k to the power p plus 1 minus k by k minus 1. If I put k, suppose sum is 4, 85, k is 4, so 4 to the power 5 minus 4 divided by 4 minus 1, what we will get? P is what I don't have. Yeah. It's full of maths, bro. Plus 4. Now 4 to the power p plus 1. I'll have to use log over here, which will be p plus 1 log 4 base 2 is equals to log of 259. Now p plus 1 is equals to log of 259 divided by log of 4, which will give something and which will finally give me p. Okay, total math. Okay, gp, where is it? What is the maximum value k can be reached for the current constraint of n? Can we pre-calculate for each n if there is appropriate k? So for the current given constraint, you can pre-calculate whether it is possible to obtain each n for some k. To do this, we can iterate through all possible 2k from 2 to the 10 to 10 to the power 6, all the k values, and for each item calculate the value 1 plus k square one plus k square plus k cube For this version of problem, it is enough to calculate value for p is lesser than 20. K to the power p. Minimum number of snowflake layers is 3. Therefore, the calculation starts from value 1 plus k square. So it's a mathematical log n. So he's taking k, all the k values from 2 to 1000. Fine. Now what he is doing is k will start from to the power 2. Obviously will start from there. K plus 1 we are taking in value because we know the starting two values. So we have 1 plus k square plus k to the power 3 dot k to the power p, right, which is equals to some 325 value. Now need to find k. So he's going over all the k values from 2 to 1000, and these two values will be basic. He added up, he started from here, that is value from 2, k to the power 2. So k to the power 2, he is going till k to the power 20 because the constraint is going till 10 to the power 6. So k to the power 20 will be fine enough to, p is equals to 20 will be fine enough for solving this question. So for every time what he is doing is p is equals to, he found k square, he k square. Now value, in value he is adding this p, k square, and again he is multiplying k in this, and if the value goes beyond 10 to the power 6, it breaks. 1e power 6, it breaks. And every time he is inserting nums dot insert val in a set, and okay, it's a simple going full brute force approach, like finding all the possible values, and keeping it in set. Now at last we are checking in nums whether at last, after doing all these stuffs, he is checking whether it is present or not. If the value is present, then it is possible, else it is not possible. So it was kind of full brute force approach going. I was thinking of making some formula and doing with that formula, but it's going with full brute force only, because we can go till 20 only, which is like I would say if k is even 2, 2 to the power 20 will like obviously reach near about to 10 to the power 6 or something, which is nothing but 4 to the power 10. 16 to the power 5, approx 16 to the power 5. I don't know what the value it will calculator. Where is the calculator? 16 into 16 is equals to into 16 into 16. What? Oh, sorry. Into 16. That's three times into 16 into 16, that is 4 times, into 16, that is 5 times, into 16, that is 6 times. 1 2 3 4 5 6. So if we are going 6 times, means one more value, so it will go beyond 10 to the power 6. See, the value is 10,004 8 something like this. So till that value we are going. So 16 to the power 5 is maximum. 16 to the power 6 we cannot go. That's why he is taking only till 16 to the power 5. Okay, this was full brute force approach. I don't think that now solving this question will make any sense, because I have already seen the solution. It's fine enough. But it was a GP question, geometric progression. I forgot everything about GP. No, not everything, but still many things. Okay, fine. Okay, now let's take a 10 minute break, and after that we'll continue again. Not a long break, short break. So after 10 minutes of break we'll be back again. We'll try to solve more question. This was, even though a simpler one, but I confused a lot, but it's fine. Let's see. Okay, I'll be back in 10 minutes. I'm back. Let's solve questions. Okay, so we saw this question, simpler version. Rudolph and Snowflake. It's quite good. It was quite good question. Um, Not trying to solve this question because no, I already saw the solution for this, so it's fine. Let's go. Let's solve this question. Let's see what this question holds. So you are given an integer array a1, a2 till an. All its elements are distinct. Fine. First, you are asked to insert one more integer a n plus 1 into this array. Okay. So first you are asked to insert one more integer, that is a n plus 1, into this array. Should not be equal to any of the value. Fine. Then you will have to make all the elements of the array equal. At the start you choose a positive integer x that is greater than 0. In one operation you add x to exactly one element of the array. Note that x is the same of for all operation. Okay. You add x to exactly one element of the array. What's the smallest number of operation it can take you to make all elements equal after you choose a n plus 1 and x? Okay, okay. The first line of each test case contains a single integer. Integer a1, a2, all are distinct. It's fine. So the sum of n over all test cases does not exceed. Okay. It's fine. That's fine. Let's see. For the first test case, we have n as 3. So we are given 1, 2, 3 as our array. And we need to insert a element at the last and select a x value and then make everyone. Apply the operation 3 times to the first element, 2 times to the second element, 3, 1. Okay, so okay, something. So the n plus 1 element should not be equal to any of the element that is inside this array. So maybe we can take an element something like 1, 3 and 4 is there, so I can take a 2 over here, and to make everything equal I need to add. This is only add operation. This is only add operation. So I can make 1, 2 by adding 1. So I cannot make a value I need to add, so I need to find the largest value that is present in the array. That's one thing that I need to figure out the first. So 1 minus 19, then 17, then negative 3, and then negative 15. These are the value. I know that 17 is the maximum element. I need to make every element close to this element, or even equal to this element, or even I need to have a value which is not present over here, maybe 16. I can add a value 16 at the last. An plus 1 has 13, any value, and I need to make everything as equal to, uh, and I need to select x. So in order to see, either make it equal to 17 or something more than 17. So if it is possible for me to make a value equal to 17, so for 1 to make 17 I need 16 more values. For negative 19 to make 17 I need negative 19, obviously, uh, to make it 0, plus 19 to make it 0, and plus 17. So 19 and 17, both I require. So it's 36 is what I need to make it equal to 17. 17 to make it equal to 17, 0. Now 3 required, 17, 18, 19, 20. I need 20. For 15, 0, 15 is required, and then 17 plus 15, that is 32, I suppose. 32. Yeah. So this is what I now I need to take x, means I need to take highest common factor from here. From all these values I need to take a highest common factor. So whatever HCF this will give me, I can take a value if the value is not present over here, I can take some value which is closest to the largest value that I have. So this value minus that value, so 17 minus 4, if it is there, so 17 minus 4, 13. So we can take 13 as a value, 13 because 13 is not there, and 4 as x. Need to make every value equal to the last value and find HCF, highest common factor between them, then highest common factor between them, HCF, highest common factor between two numbers. How to find highest HCF of two numbers? C plus code. I think there is a STL for that. Hey, see, I have this GCD underscore underscore. Oh my god, how many times they'll call me? Uh, 1 minute. I'll be back. I'm getting a call. Okay, so this is a GCD formula, greatest common divisor. I can use this. Why to go for anything else? Okay. So every time I have to find the GCD. The values with the last and the value which I want to take. It might be the number minus the GCD that we got. If that is not present in my array, I'll simply use that number, or or if we go one more plus, adding this number is the only thing. Now I know how to find the GCD. So we getting an value. Sorry. So we'll be getting this num, insert and equalize. The first thing that I will do is sort. Pass. So this is an now if I is equals to 0, if this is the first time we are facing this, so GCD will be nothing but the value itself, nums of n minus 1 minus nums of I. Else my GCD will be equal to underscore underscore GCD of A of GCD comma now if I should not go to the last element, because last element will always be 0. Different norms of n minus 1 minus norms of I will be 0, and the GCD will be 0. So greatest common divisor will give me 0. Okay, I got the GCD for this. Let's print the GCD. Check. So for first case it's 1, for second case it's 4, for third case it is 0. Now the only thing that matters here is how to add the last element. What should be there in the last element? If it is a distinct element set, maybe I can create a set of integer st, which will be nothing but populated with nums dot. Now if value is there, suppose if last element minus that GCD is there present in set, now what we will do? Now what? Now we need to add some value to it. And if we add element more than that GCD, more than the last element, the largest element, add GCD to it, that will give me that will give me times now if what I will do, new element is nothing but nums of n minus 1, while new element is equals to nums of n minus 1. Abhi we need to find times. If that element is present in set, I'll subtract 4 more to it. Why we are trying to subtract values? If st dot find times new element minus times into nums of n minus 1 is equals to st dot n. So the new LE will be equal to I'll answer. New element this will be something but GCD, if GCD comes out to be 0, if GCD of that array is 0, that means what? 3 and 4 is no common element. Let's see if
whatever value will get divided with GCD and add it in our answer. Hi, 30. For the second, what's the new element that I got? Chi 27 and ek. But I'm not handling any this last case properly. You see, if I remove this, if GCD is 0, then what? It will create a problem. If GCD becomes 0, I need to handle that case. How? Even if nums dot size is equals to 1, directly return 1. If GCD is 0, now suppose the number is 2 and 3. So for 2 comma 3, the GCD will be 0. We don't have any GCD for this. Now what to do in this case? It's like 2 it's 2 No, this has some problems. This has some problems. I can guarantee that. And it is with the help of GCD. I'm pretty much sure about it. We will attempt to make all elements equal to the current maximum value in the array. That's fine. Pick some x. Now, how to check if it's possible to make every element equal to the maximum? Well, for one, the difference between the maximum and the element should be divisible by x. So, for all element, all differences should be divisible by x. Thus, the greatest common divisor GCD for all difference should be divisible by x. That's fine. That's fine. I am doing same thing. Among all values of x that works, we should obviously pick the largest one. The answer equal to increases with the increase of x. Thus, it only makes sense to make x is equal to GCD of maximum minus a1, maximum minus a2, fine. This is what I did. This is what I did here. I found GCD by maximum minus that value, by finding maximum minus that value with the GCD. That is fine. If you think that about that the perspective of Euclid's, I that's fine. With that implementation, it's clear that it never makes sense to make all elements equal to anything greater than the current maximum. X will still be required to be divisible by all the adjacent differences, but you will be adding one more condition to that can only decrease the GCD. Correct. Let's return to the insertion. First, inserting a new element can never decrease the function. You will add one element constraint to the GCD, a n minus 1, n plus 1 minus a n. If you increase the maximum value in the array, if you increase, here is something, if you increase the maximum value in the array, all n elements will need additional operations to become equal to it instead of the old maximum. If you don't change the maximum, a n plus 1 itself will need some operation to become equal to the maximum. Correct. Correct. Since x can only decrease, let's try not to change it at all. So we only add an element of form a of I plus x k for any integer k. If it doesn't appear in the array, since all elements of the array are also of the form of any I, let's instead choose ai, that is maximum of the array. So the form is maximum of the array plus x into k. The maximum increases. Thus, this is what I'm doing in the second half. This is what I'm doing in the second part. Minus. I'm subtracting. Thus the answer increases. Since all elements will require k extra operations, obviously it doesn't make sense to pick k greater than 1, since max plus x doesn't appear in the array already, and the number of extra operation for this is the minimum possible, just n. If we choose a negative k, no other elements are affected, thus the answer only depend on the number of operation that a of n will require. So the best option is to choose the largest k such that max plus x into k doesn't appear in the array. Worst case, k is equals to n minus n if the elements are something. That's fine. The number of operation is required minus k, so it's mm, thus we come to the final algorithm. Calculate x, that is GCD of this for n1. It's 0, so we now here is the thing. If it is 0, we need to handle it separately. The answer can always be 1. The initialize k is equal to -1 and keep decreasing it by 1 as long as max minus k x into k appears in the array. That can be checked. Hey, so we handle it separately. The answer can always be 1. If GCD is 0, the answer can always be 1. Why? Okay, one operation. Exactly, yaar, exactly. Why didn't I realize this? Why I didn't realize this? If GCD is 0, I'll have to multiply all the elements to find the common, and x will be something which will move till oh god, oh god, oh god. Should have should have realized this. Means the solution is not wrong, it's correct. Let me try and submit it if possible. Let's see. Insert and equalize. Let us see, let us see, let us see. Test case 1, test case 2, it went correctly. Is it because of long? I am doing something wrong. Let's take long everywhere. Not even miss. Under shit. नहीं Do we have wrong answer? First number different. Checker comment. This is my output and this is jury's. I think it is because of long only. Let's see. I should have tried. Okay, it went to 26 test cases. Okay, I was correct. I was correct. All the time I was correct. I didn't even realize this. That all the time whatever I did was correct. If GCD is 0, that's the only thing. Return 1. Fine. So this was a great session. I would say I loved this session. I got to learn lots of things. I got to like recall many of the things which I forgot. But now I think it's really getting the flow. I'm getting into it. So slowly I think I'm able to understand the problems, how to approach to it, and how we can solve it. So it's nice. It's really good to have these things. I think I'll stop here today. Uh, we'll continue next week. We'll be back with another live stream with another good questions, and we'll solve those questions again. And yeah, so I hope you enjoyed. I hope you guys are also having an amazing day today with solving some great questions. So hope to see you again in near future, in coming weekend, next Saturday. So thank you all for joining in. Thank you very much. See you next week, Saturday, same timing, with some more good questions. So I think 1300. I'll try to solve more questions of this. What, insert and equalizes there also, insert and equalizes there. So in future we'll be solving more questions more related to this uh, code forces question, and yep, we'll brainstorm more. So see you guys next week. Thank you for watching. Do like, share, and subscribe my channel. Thank you. Bye bye.